Assalamu alaikum wa rahmatullahi wa barakatuhu. Welcome to Hasib Electronics. Friends, in this video we will discuss a feedback circuit. Feedback circuit in any switch mode power supply. In last video I discussed about switching mode power supplies. So in this video we will discuss feedback circuit, that is the most important circuit for regulation. अगर आप ये वीडियो उर्दू में देखना चाहते हैं तो जो ऊपर आई बटन नज़र आ रहा है, ये कॉर्नर में जो राइट साइड पे कॉर्नर में आई बटन आ रहा है, इस पे लिंक पे क्लिक करें तो आपको उर्दू में यही वीडियो आपको उर्दू में मिल जाएगी। और उर्दू देखने के लिए, ये वीडियो उर्दू में देखने के लिए आप मेरे चैनल हसीब इलेक्ट्रॉनिक उर्दू को देखा करें, वहाँ पे सेम वीडियोस उर्दू ट्रांसलेशन में आपको मिलती हैं। We will discuss feedback circuit. First of all, we have to understand what is the feedback. Feedback, before discussing or going in detail, I will discuss. We have a potentiometer. I have a power supply. See it carefully because I share my experience. I don't want to hide anything. So if our concept is clear, then there is no problem. I have 3 volt power supply. I have, suppose it is a voltage regulator. It is a voltage divider. It is a potentiometer. I will connect one line here and I will take common output from the same terminal and I connected here the output, and I connected at the center point. I am taking 495 volts, 0.495 volt. If someone say I need 0.5 volts, that means these voltage are less, 0.005 less. So I am asked, it must be 5 volt. What I will do, I will see these voltage level on this screen. My brain will calculate, and one signal will come to my hand and I will rotate slightly to increase. Now I increased. If the voltage are increased, I see from my eyes, my brain calculated and again issued a signal to my hand to decrease it until it is 0.5 volt. It's 0.5 volt. Now I watched from my eyes. It is a complete chain. I detected from how I detected. When I was seeing it, it was down level. How I determined? My brain calculated it. Required value is 0.5 and here are 0.495. So my brain gave a feedback signal to increase the voltage. That is called positive feedback. To increase the voltage, that is positive voltage. When it was 0.502, suppose it is 0.5818, so then my brain will generate a negative signal that will call negative feedback. So this is feedback. When these voltage were down, my brain asked to give positive feedback to increase. When the voltage level was high, there was a negative feedback to decrease it. If this concept is cleared, then we will correlate this system, my eyes, my brain and my hand to rotate this potentiometer. Then it's very easy. If we design a circuit, here is output, this one is output, a feedback circuit, feedback system. This loop, my eyes, my brain and this my eyes and my brain make a signal to this PWM is my hand, and this switching mechanism. My hand, this is a link. If I will use a PWM, pulse width modulator, who will determine all this, then this switching regulator will increase or decrease the voltage level. It will work like this. When the voltage will go high, it will decrease. When these are decreased, it will increase. It will keep working like this. The switching regulator will move like this to get the voltage at standard fixed voltage. Here I have a complete circuit: pulse width modulator, feedback circuit and inverter circuit, chopper circuit. Feedback circuit will sense the level of the voltage and it will give to the pulse width modulator to increase or decrease the switching level to get the required voltage level. There are many types of regulations. Output current. This system can sense output current. If the output current is increased, resultant the voltage will decrease. When the voltage will decrease, that means over current will cause under voltage. When under voltage, this system will give a feedback to increase conduction level, to take extra output to compensate the overcurrent and to maintain the voltage level. If the voltage level are higher than the required level, then this feedback circuit will give a negative feedback to pulse width modulator to decrease the switching level. So this is a closed loop and it is continuously monitored, and if input voltage are increased, it will decrease the switching level to maintain the voltage. If the temperature is increased, this system will increase or decrease the switching level to compensate the temperature effect on the components. We use optocoupler and a voltage reference. Here is a potentiometer. Potentiometer is an analog switch. We know the BJT, bijunction transistor, that is used to make a conduction. It is also used as a linear switch. It is also used as an amplifier. When we use it in class A, class B amplifier, that time it makes a linear switching like a potentiometer. When we make a correct biasing for this transistor, it will behave like a potentiometer. When we make a special biasing for this transistor, it will behave like a potentiometer, like this. It will need increase, decrease, increase, decrease. This is the BJT, bijunction transistor. But in optocoupler, there is a special transistor that is called phototransistor. Phototransistor have emitter, collector, and then there is no base. At the base there is a window, optical window. This optical window will sense light. When we use automatic light sensors to turn on, turn off our street lights and different types of photo job projects, then we use light sensor. Here we have LED, light emitting diodes, in this package. We have one component here, that is 4-pin component. This one, it have one side LED, output, two terminals, emitter and collector, and the light which drives the base, that is encased in this package, so that the external light will not affect on this base. This is encaged, two components, one light and one phototransistor. How it works? We will see some examples. If we see this design, we have some voltage level. This ground, this is driven by a LM311 operation amplifier, and this voltage level comes here to the diode of the LED of the optocoupler. And if we see any power supply, any power supply, it is two sections, hot section, cold section. Hot section and cold section, that are just only two couplings. One is electromagnetic coupling. Here is magnetic flux, that is called to induce voltage in secondary. And here we have a light coupler, opto-isolator. It's optocoupler, it have also name opto-isolator. So this opto-isolator, what will do, it will give a feedback from the output. How much there are voltage, if there is short circuit or if there are regular voltage, this voltage will be sensed by this system. Here is a standalone intelligent Zener regulator, a reference diode TL431. This component, 3-terminal component, it will sense the voltage in this area. If there is a short circuit, it will detect the short circuit and then it will give a feedback, pulse width modulator circuit. Now we will check step by step. This feedback circuit will go to the pulse width modulator, pin number 2, pin number 3, pin number 1. Any IC have a different, every IC have a different pin out, different drive circuits, but the function is the same. So here the ground, in this case the ground level will started from here and it will switch to this IC. The how much voltage are taped, it depends upon the conduction level of this phototransistor, and phototransistor is controlled by the light of LED from this network. If we see here is 12 volt and one is negative line connected here, and 13.5 Zener. This is just only a regulator for overvoltage. If the overvoltage are here, it will increase the switching and then this voltage will start from here and it will disable this FET. This voltage from here, if you see here, and it will stop switching. So next, if we see here is a voltage regulator, voltage output, and then there is a network. Some resistors are installed to bias up this optocoupler, and this optocoupler will give light to this transistor, phototransistor, and it will take a rectified voltage and it will make switching to this IC. And this MOSFET IC will drive this transformer, and we will take output in the output area. If the output will decrease, it will increase the switching to increase the voltage. If the output voltage are increased, it will decrease the switching level to decrease the voltage at the specific level. Same as here. Here is also a sense line. The voltage are sensed here, and then it is controlled to feedback circuit. This feedback, sometimes this feedback is used only to check over voltage. Sometimes it is used to regulate the voltage. Sometimes it is used to, if we see this 594, these voltage are applied to pin number 16 and pin number 1 to control the under hour voltage, to maintain the voltage within one window. Upper limit and lower limit are defined from these potentiometers, these optocouplers. If we see here we have 2.5 volt reference diode TL431, and this voltage are applied to this LED optocoupler, and optocoupler is causing switching to optotransistor. This phototransistor drive to pin number 3 of this IC, and this IC, MOSFET IC, will drive this circuit. If the output voltage will increase, it will decrease the switching. This will negative feedback. If voltage are dropped, it will increase the switching. And this voltage feedback area is also combined with this coupler. So now we will see practically what happens. Here is no IC. Here is no IC, just only here are some components and one FET and this standalone chopper inverter, and here is also a feedback circuit. So we will connect this feedback circuit and we will check the response of this circuit. Here are 5.1 volts, and this time I am getting voltage 1.06 volt in the input of this optocoupler, and I connect 5 ohm resistor to the output. Then we can see the voltage are dropped. Here is 1.067, 1.06766. If I connected the load, it will be 1.5058. I connected this load. So it is at input. And what is the change at the output of this voltage, this optocoupler? I will see now. This time the output of optocoupler is 0.39 volt. Its conduction. And when I connect the load, check the output of this optocoupler. I connected 5 ohm resistor to 5 volt. That means it is taking 1 ampere current. We can check the output voltage of this optocoupler are changing to change the conduction level of this MOSFET. We will see another circuit. I will check this circuit. It have a IC. We will check pin number 3. This IC pin number 3 is connected. It's feedback circuit. We will check feedback circuit and we will check it with ground. Input ground, that is. If we see here, I am taking varying voltage. In this circuit, the output voltage are not stable. So if we see the pin number 3 of this optocoupler, of this IC, that's also not stable. If we check the output of this optocoupler, it's not working. If we see voltage at the input of this optocoupler, we are getting a varying voltage at the input of optocoupler. So that means the optocoupler or the feedback circuit is not good. It has some problem because the output voltage are varying. When we have varying voltage in the output, then the problem in this reference optocoupler, this IC is working, it's good. So we have problem in this optocoupler or in this area. We have to find where is the problem. I uploaded a detailed troubleshooting procedure for feedback circuit. We can see here is no output. It is not making any conduction. Maybe this one is damaged. So we can check the pin number 3. We can see pin number 3, it should take 1 volt. If we cannot take 1 volt, that means there is problem in this area. What is the problem in this area? Because the drive voltage of this optocoupler are not present. It should be 1 volt, 1.08, 1.09 volt to drive this circuit. So we have something short in the output area. Now I will connect another power supply and we will check the response. Ground, and first output I have 3.6 volt. Here I have 30 volt. At the input of this optocoupler I have 1.04 volt. And now I will make some short circuit for this, and here I have 5 or 6 sections. First of all, you have to determine where is the actual circuit connected. This circuit is connected to this load line 5 volt. So I will make a short circuit for 5 volt for this area. Yes, this is 5 volt. So I will connect to this optocoupler, and I will connect our load. We can see it is 1.04 volt. When I will connect our load resistor to this, the voltage will decrease. When this will decrease, I am taking the output 0.57 volt in the normal condition. When the load is connected, it will increase the voltage. So it will give a feedback. Normally I am taking 0.57 volt in standard condition without no load. When the load is connected, I will take 0.57 volt. Sorry, if I will connect the load, I will take more voltage. And if there is a short circuit, it will disable the output. The power supply will try to turn on again and again that there is a short circuit. So this feedback circuit is used to monitor the proper functioning of the power supplies to regulate the voltage. If this video is good for you, please like, subscribe and share. If this video is useful, you can share this video with your friends. If any YouTuber wants to upload my video to his channel, I permit, because this video I am sharing Creative Commons video, so anyone can upload this video to his channel, so that the knowledge must be spreaded to everyone. Thanks for watching. Assalamu alaikum wa rahmatullahi wa barakatuh. Bye bye.